Hey everyone, welcome back to Zero to SOC. This is episode 1 of my Network Plus series, and today we're kicking things off with something pretty foundational, network topologies. Basically, the different ways devices can be arranged and connected. Let's just talk through it. What even is a topology? A topology is just the layout of a network, how everything is connected, and how the data moves around. There are wired topologies and wireless topologies. But for this episode, we're sticking with the wired ones because they show up everywhere in the exam and in real life. Star topologies is the first one. Let's start with the one you'll see the most. Picture a bunch of devices all plugged into one central point, usually a switch or a hub. Everything goes through that central device before it gets where it's going. Why it's great? If one computer or one cable dies, the rest of the network keeps working. Each device has its own dedicated connection. And why it's not so great? That central switch, yeah, if it dies, the whole network goes down. That's what we call a single point of failure. Now, with mesh topologies, that's the next one on our list here, which is basically the everyone talks to everyone layout. Every device is connected to every other device. It's super redundant. If a connection fails, traffic can just take another path. The upside, it's incredibly fault tolerant. The downside, it's expensive. Lots of cables, lots of network interfaces. So you won't see this in small office networks. But you do see this in a very important place, the internet. The internet is basically a giant mesh of routers all over the world. This next one's a little simple, point-to-point topology, two devices connected directly with a single cable. It could be two computers, two routers, a router and a switch, whatever. It's the simplest topology there is, and it shows up everywhere. Hybrid topologies, it's most real networks aren't just one thing, they're hybrids. It's a mix of star, mesh, point to point, and whatever else makes sense. Companies combine topologies based on cost, performance, and redundancy needs. Now let's talk about something more modern and very common in data centers, spine leaf topology. Think of it like this. You've got spine switches, those are your backbone, and leaf switches, where servers connect to. Every leaf connects to every spine, but leaves don't connect to other leaves, and spines don't connect to other spines. Why this matters? No matter where traffic is going, it only takes 2 hops. That means low latency, fewer bottlenecks, and lots of redundancy. This is the go-to design for large enterprise networks. Now, Cisco has also made a nice model for these for making large networks, the 3-tier hierarchical model. And basically, it breaks the networks up into layers. You have the first layer, the core layer, that's the backbone. It's high-speed switches and routers, move large amounts of data, and connect internal and external networks. Layer 2, the distribution layer. This is the middle layer. It routes traffic between core and access, which is the next layer. It applies policies and filtering and uses routers and layer 3 switches. Then there's the access layer, where users connect. It has switches, computers, and devices, provides access to applications and resources. Now, for smaller networks, you don't need all 3 layers. There's a collapsed core model, and this combines the core and distribution layers into one, but it keeps the access layer. This creates a 2-tier model that's cheaper and simpler while still giving you good performance. And then with all networks, there's traffic flow, and there's different names for traffic flow. So we're going to go over how traffic moves inside and outside a data center. You have east-west traffic. Now this traffic is within the same data center, server-to-server communication, internal workloads, that kind of stuff. And then you have north-south traffic. This is traffic going in or out of the data center, client to server or data center to data center. Understanding this helps you design networks that avoid bottlenecks and handle loads properly. Now, to wrap up, that's the first section of Network Plus, network topologies and their types. We covered star topology, mesh topology, point-to-point, hybrid, spine leaf. There's the 3-tier and collapsed core models, east to west versus north-south traffic. Now, these concepts show up everywhere in the exam, in interviews, and in real-world environments. Next episode, we'll keep building on this foundation and move deeper into the fundamentals. Thanks for hanging out with me, and we'll see you in the next one.